Students, you're most welcome to this episode. To hope the other one went well, that is the second fundamental topic. Today we are looking at the third fundamental topic, that is linear equation, right? So as usual, as we do it, I want to introduce you to the topic so that in our next lesson or our next episode, we will deal with the main subject as in linear equation. Alright, now what I want you to know is that equation is different from an expression with something very little, and what I'm talking about is an equal to sign. So equation is what links two expressions together, right? So the difference between equation and expression is expressions do not have an equal to sign, but equation has an equal to sign, right? So for example, if I have something like 2x plus 3, this is an expression, right? And I have something like 4x minus 2, this is also an expression. Now, if these expressions are linked together with an equal to sign, then it changes to what? An equation, right? So an equal to sign links two expressions together, which changes it to what? An equation. Alright, now that you know the difference, now, also in equation, because of this equal to sign, it creates a barrier. Because of the presence of the equal to sign between, that is in an equation, it creates a barrier between the left-hand side of the expression and the right-hand side of the expression. You get it? Now, which means that if one of these expressions has to cross this barrier, then the sign changes. That is also one thing you have to note. Because of this barrier, if any of this sign crosses to the other side of the barrier, then the sign changes. That is to say, if it's positive, it takes the negative sign. If it's negative, it takes what? The positive sign. So for instance, if I want to simplify this equation, I have 2x. Since I want to collect like terms, I will bring this 4 here. And because this 4 is positive and it crosses it's crossing the equal to sign, which is the barrier, it takes what? A negative form, negative x. Are you getting it? Then it goes, I have negative 2 here, then this 3 crosses to what? Negative 3. Then I go on like that, right? Another thing you have to also note is that in equation, whatever you do to the left-hand side of the equation, you apply the same thing to the right-hand side of the equation. Now, in fact, what even happens in equation is, when I have an equation like this, I have something like 2x plus 3 equals 4. And I want to actually simplify x. Now, originally, that's the right thing I'm supposed to do is to, because I want the 2x to stand alone, I have to subtract 3 from both sides. So that this will cancel this. So I'll get 2x equals 4 minus 3. This is how it's actually supposed to be. Are you getting it? So for instance, here, I should have subtracted what? 3 from both sides. And then I'll also subtract 4 from both sides. But because it makes it quite complicating, most teachers, which including myself, will say that if you want to simplify, just shift these ones toward the other side of the equal to sign. Are you getting it? Yeah. And then one last thing I want you to understand is that, you see, when I have something like 2x plus 3 equals 4, right, sorry, if I have x plus 3 equals 4, then I can easily move, because these two expressions are separated by an operation, they are not together, I can easily move this there. So this one becomes x is equal to 4 minus 3, right? But in the case that I have something like 2x plus 3 equals 4, or just 2x equals 4, and I want to what? I want to find x. I cannot shift these two there because it's attached to the x. So what I do is that, since it's multiplying, there is no sign separating, I divide here by 2 and divide here by 2, so that x will be what? Remember, in equation, whatever you do to the left hand side, you do that to the right hand side, right? Alright, so this is what we are doing for the pre-class. See you in the main class.